Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Reinforcement Learning in Practice. Training agents to solve problems. Imagine you're teaching a new puppy tricks. You don't write down every single paw movement. Instead, you give it a treat for doing something good, like sit, and maybe a gentle no for something bad. Reinforcement learning, RL, is exactly like that for AI. It's a type of AI where your program, an agent, learns by trying things out in an environment and receiving feedback, rewards or penalties. Based on its actions, over time, it learns which actions lead to the best outcomes, without you explicitly telling it what to do step by step. To understand RL, we need to know its main characters, which for a developer are key components you'll define. 1. Agent, your AI program. This is the learner. Think of it as the puppy you're training. It makes decisions and takes actions. 2. Environment, the world. This is where your agent lives and operates. It could be a game, a simulation of a factory, or even a virtual maze. The environment reacts to the agent's actions. 3. States, situations. These are the specific observations or conditions the agent experiences in the environment at any given moment. For the puppy, a state might be owner holding a treat or ball on the floor. 4. Actions, moves. These are the choices the agent can make. The puppy's actions might be sit, fetch, bark. 5. Rewards, feedback. This is the numerical signal from the environment telling the agent how good or bad its last action was. A treat is a positive reward. A no is a negative reward. Penalty. The RL process is a continuous loop. The agent starts, observes its current state in the environment, decides on an action to take, and performs it. The environment then updates to a new state and gives the agent a reward or penalty. The agent remembers what happened, state, action, reward, new state, and uses this information to improve its strategy for next time. It's like playing a video game. You try a move, see what happens, and learn to make better moves to win. As a developer, you're setting up this feedback loop for your AI. This is one of the most crucial parts you'll design as a developer. The reward system guides your agent's learning. If you want your agent to win a game, you might give it a big positive reward, plus 100, for winning, and a small negative reward, -1, for every step it takes. To encourage efficiency, if your rewards are poorly designed, your agent might learn to do something you didn't intend. For example, if you only reward winning, but not losing, it might just sit still forever. What does the agent actually learn? It learns a policy. Think of a policy as the agent's internal rulebook or strategy. If I'm in this state, I should take that action. Initially, the policy is random. The puppy just tries anything. But through trial and error, getting rewards and penalties, the agent updates its policy to favor actions that lead to higher cumulative rewards. Eventually, it builds an optimal policy that helps it solve the problem efficiently. As a developer, you're building the mechanism that allows this policy to be learned and refined. One of the most popular and foundational RL algorithms is queue learning. Imagine a giant mental table, called a queue table, where your agent keeps track of how good it is to take a particular action from a particular state. Each cell in this table holds a queue value. When the agent tries an action and gets a reward, it uses that feedback to update the queue value for that specific state action pair, making it a better estimate of future rewards. Over many trials, the agent learns accurate queue values. And when it needs to make a decision, it simply looks up the current state and picks the action with the highest Q value, knowing it's the best option. You, the developer, set up this Q table and the rules for updating it. Reinforcement learning isn't just for teaching AI to play video games, though it's incredibly good at that. You'll find RL in asterisk self-driving cars, asterisk asterisk deciding whether to brake, accelerate, or turn, asterisk robotics, asterisk asterisk learning to grasp objects, navigate complex environments, asterisk resource management, asterisk asterisk optimizing energy consumption in data centers or traffic flow in cities, asterisk personalized recommendations, asterisk asterisk suggesting the next video or product you might like, asterisk financial trading, asterisk asterisk developing strategies to buy and sell stocks. As a developer, the skills you learn in RL open doors to these exciting and impactful applications. So, what's your job in all of this? You are the architect. You will asterisk define the environment, asterisk asterisk create the rules, physics, and dynamics of the world your agent operates in, asterisk design the reward function, asterisk asterisk carefully craft the reward system to encourage the desired behavior, asterisk choose the algorithm, asterisk asterisk select an RL algorithm, like Q learning or more advanced ones, that fits your problem, asterisk set up training, asterisk asterisk write the code to run the learning loop, monitor progress, and manage the vast amount of data generated during training. You're not programming the solution directly. You're building the system that allows the AI to asterisk discover the solution itself through intelligent trial and error. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.